Good morning, and today's topic is drip irrigation system. So a quick recap of what we covered in the previous class, talking about flow irrigation and perennial irrigation. So I hope you remember the main advantages and drawbacks of the systems. So for today's topic, please go to this picture, wait for a minute, and you can note down what you observe from these figures. Okay, so you may have noticed that there are some pipelines through which water is coming and which are coming as drops or trickles down, and you can also see that water is applied directly to the crop near the root zone. And so if you adopt an irrigation system like this, you don't need to wet the entire land area just like in your surface irrigation methods. So it's more of a conserved system. And you can also see that since the pipeline system is a low pressure system, and also the water application rate is much slow, so you just need to have the water to meet the consumptive use of crop. So for today's class, the learning objectives are, you'll be able to explain the components of drip irrigation system, you'll be able to infer types of drip irrigation, and you'll be able to identify important parameters in the design of drip irrigation system. So let's see the components of a drip or trickle irrigation system. First, you should have a control head unit where you will have your water source and a filter pump. From there, the main line or manifold is starting, so of a larger diameter, and from the manifold at different locations you can have your laterals emitting from there, and the laterals are of smaller diameter than the manifold, just allow the water to move through freely. And on the laterals, depends on your crop spacing, you can have your emitters spaced at regular intervals. So when water comes through these pipes, each emitter starts trickling water down, which is so close to the plant, so water will not get wasted around anywhere. And you can see that there will be a wetting pattern developed around the root zone, so plant can absorb more water without wasting through these extra spaces. So in any drip irrigation system, you need a lot of items like tubes and emitters and some connections as well. So the head unit where the main line is starting, there should have some filter to remove the debris which is coming out of maybe unclean water. And you can also have a fertilizer tank so that you can mix the chemical fertilizer along with the irrigation water. It's called fertigation. Fertilizer application through irrigation is called fertigation. And you can have a water meter and pressure regulator to control the flow rate. And the main lines and laterals which are of PVC tubes or PVC tubes, and you need emitters which are of generally plastic materials. So emitters can be of fixed type or variable type. The efficiency of a drip irrigation system depends on the emitter's uniformity, and you can calculate it as emitter uniformity times application efficiency is the irrigation efficiency of a drip irrigation system. Now the design aspects of a drip irrigation system you can see like this. You need to cover this entire area for irrigation, and your water source is somewhere here. So you can see how to align the main lines and how to align the laterals. If you are having a land of varying uniformity, you should know how to align the laterals and mains, and you can have all the emitters on the laterals. So this is how an entire drip irrigation system looks like. So some of the aspects of design for the pipes, you have to find out the diameter of the pipes based on the discharge and the available pressure head. It's mentioned that the head difference between the emitters should not exceed 10 to 15% of average head. And for a minimum cost, the maximum allowable head should be on the laterals than on the manifold. So I hope you understand these concepts clearly to do an example on this topic.